Miss Dawn, can you hear me now?
Yes. The numerator is the top of the the bottom.
Sorry?
Is the numerator the top?
Yeah, so I can't hear you. I don't know what happened, but someone logged in from my account and it kicked me out. So you're talking about the diagram? Miss
Can you hear
Dawn,
me,
can you
Mr.
hear me?
Vipul? Can you hear me, Mr. Vipul?
Yeah, Mr. Dwayne, I can hear you. Hi, good morning.
Good morning.
Okay, so we have two people. I don't know where are others. So let's wait for 2 more minutes, then we'll start with the class. Till that time, you can read this diagram and you can, try to understand what this is saying, and then, we'll come back again to the diagram. Yes, is the numerator the top or the bottom? So it's the top. Good morning, Miss Anderson. Yes, Miss Dawn, please go on.
Okay, you said divide the numerator by the denominator. Okay, the numerator, the top is the top one, right?
Yeah, it is.
Okay, so I'm dividing the bottom one into the top one,
Yeah,
right?
yeah.
Okay.
Okay, so this is our basic diagram that we will come again and again to. So let me explain you. So this is fractions. So in order to convert a fraction into a decimal, suppose we have a fraction like this one, 2 over 5, and in order to convert it into a decimal, what we do is we divide in this way and find the answer. We put the decimal here, we put the decimal here, we put 4 here, we put 0 here, we say it is minus 2.0, the answer becomes 0. What I get is 0.4. So if I have a fraction like this one, what I do is I divide the numerator with the denominator and get my decimal. Now if I have a decimal like this one, if I have a decimal like this one, 0.2, and I want to convert it into percents, what I do is I multiply it by 100. 0.2 multiplied by 100 is 20. And if I have a percentage like this one, if I have 35% and I want to convert it into decimal, what I do is I divide this 35 divided by 100, and because there are two zeros in the denominator, this two zeros will need two digits in the right of the decimal, so I'll write this as 0.35. Now in the same fashion, if I have 35 percentage and I want to convert it into fractions, then what I do is I write 35 as it is and I put 100 in the denominator and then I try to reduce it. Do you all understand this one? So you can write this into your notebook.
I'm trying to write it all down. I'm trying to figure out what you're saying.
Okay, so Miss Dawn, yes, you're saying something?
Instead of us simplifying that, can't I divide it to make that into a fraction?
Yeah, so if you try to divide 35 by 100, what you will get is 0.35. And 0.35 is a decimal, it's not a fraction. So in order to get a fraction out of 35 over 100, you have to reduce it. So how you reduce it is first you try to divide both of them by 2. You will be unsuccessful. Then you will try both of them to be divided by 3. You still can't divide 35 by 3. Then you try 4. Then you try 5. Now 35 can be divided by 5. So it will be 7 and 100 divided by 5 will be 20. Then again you will try to divide both of them by, start with 2, then you will be unsuccessful, then 3, then 4, then 5, then 6, then 7, and you will find that it cannot be further reduced. Hence this is the answer.
Okay, but you always start off with the number 2?
Yeah, so yes, you always start with the number 2, then you check for number 3, then if not, then you check for number 4, then 5, then 6, then 7, then you go on like this.
Okay, thank you.
Okay, yes. Okay, so this is about conversion. Now let's remember how we dealt with comparing two fractions. Now, if we have, you remember what fraction is, right? The feel of the fraction is that I have 3 total parts, and in this fraction here, I have 2 parts out of 3. And in this fraction, I have 1 part out of 3. So which one will be the bigger fraction? So the answer was, when the denominators are same, we simply compare the numerator. Whichever numerator is bigger. Okay, yes, Mr. Dwayne, go on, please.
Yeah, when you that 2 times 100, you got equal 20. How do you get 20 if it's 200?
Okay. Okay, it was 0.2. It was not 2. So there was a decimal. It was 0.2.
Okay.
Yeah, I was demonstrating on how to convert decimals into percentages. So 0.2 multiplied by 100, it will be 20%.
Okay, I see what you did.
Thank you. Okay, so coming back to comparing the fractions, when the denominators are same, we just compare the numerators and find who is bigger.
2.
Yeah. So now the addition part. Now how to add the denominators? How to add the fractions? So 2 over 3 plus 3 over 3, we simply, because the denominators are same, we simply write the denominators and add the numerators, and the sum will be equal to 5 over 3. But what happens when the denominators are not equal? So 2 over 3 plus 4 over 5. So what happens when the denominators are not equal? So when the denominators are not equal, we try to make them equal. And how to make them equal? We multiply them with each other. Okay, so 2 over 3, okay, 2 over 3 gets multiplied with 5 over 5 and added with 4 over 5. Now this 4 over 5 will get multiplied by 3 over 3. We solve this one. 2 multiplied by 5 is 10. 3 multiplied by 5 is 15. Added with 4 multiplied by 3 is 12. And 5 multiplied by 3 is 15. And the answer is 22 over 15. Why we did it easily? Because now the denominators are equal. Yes, Miss Tiffany, go on, please.
Why did you do the 3 times 3 over 3?
Okay, so we learned this in the addition of fractions, that when the denominators are equal, we can easily add them together. So here I wanted to make the denominators of this both of these fractions, 2 over 3 and 4 over 5, I wanted to make the denominators equal. So I multiplied them with each other. I multiplied 5 with 3 and I multiplied 3 with 5. So here 2 over 3 gets multiplied by 5, but because I multiplied something in the denominator, I have to multiply it in the numerator as well. Why? Because this will make 5 over 5, and 5 over 5 is essentially 1. And in the same fashion, I have to multiply 3 with 5, and because I multiplied 3 in the denominator, I have to multiply 3 in the numerator as well. And by this process, I'll get equal denominators in both the fractions. Did you get this?
I get it. You just did like reversed it, like you said, 3 times 3, and then you did the 5 times 3, but you put 5 and 5 and 3 and 3. Okay.
Yeah. So that's how we add two fractions with unequal denominators. Now, how to compare two fractions with unequal denominators? 2 over 3 and 3 over 4. Now, how to compare them, which one is bigger? So what we do is, again we apply the same procedure and we make the denominators same. So what we do is we convert 2 over 3 and we multiply 2 over 3 with 4 over 4, and we multiply 3 over 4 with 3 over 3. So the answer will be 8 over 12, and this answer will be 9 over 12. We know 9 is bigger than 8, and hence we found the solution, and we found the solution. So this is how we compared two fractions. Now, subtraction of two fractions is similar as addition of two fractions. 3 over 4 subtracted with 2 over 3. I want every one of you to do this in your notebook. Use the same method as what we did in addition. Just instead of addition, these fractions will now be subtracted. So everyone, please do this in your notebook. First, make the denominators equal and then solve it. And write the answer in chat. Okay, so Mr. Dwayne wrote the answer. Let's see what others get.
See, it's subtraction, right?
Sorry?
Is it subtraction? We know it's
Yeah,
subtraction.
this is subtraction.
I'm trying to figure out what did I do wrong. How they getting 112?
No, it's fine if you get 112. It's
I
fine.
didn't
Yeah.
get 112.
Okay, if you did not get 112, that's fine too, because 112 might not be the answer.
Well,
Um, I
if you
don't know.
multiply the 4 by 3 and then the 3/4 by 3, then you multiply the 2/3 by 4.
We doing subtraction. We not doing
Yeah, you
multiplication.
do the multiplication first, then you subtract from there.
Yeah. So for your
But
reference, you can.
subtraction.
Yeah. So I'll solve this. I'll solve this for you guys. But for your reference, you can see the addition. What we did in addition. So the goal is to make the denominators equal, so that we can do our operation of addition or subtraction very easily when the denominators are equal.
Right.
When the denominator is not the same, we trying to make the denominator the same.
Yeah, we try to make the denominator same. Yes.
I don't know. I'm confused. I'm not gonna answer this because I'm trying to get a better understanding. Because I guess because I put me in late. I don't know.
Okay. Okay. Sure. So I'll explain you how to do this. So let's see the question. The question says 3 over 4 subtracted with 2 over 3. So how we do this is we want to make the denominators equal. Now tell me something. If I multiply 3 over 4, okay, I'm sorry for the bad drawing. 3 over 4, if I multiply it with 1, does it change the number?
Mm.
No, right?
No.
So I can multiply it with anything I want. Okay, Miss Anderson got 1 over 12 as well. So yeah. So now 3 over 4, if I multiply it with 1, I won't change the number. So I try to multiply it with something that will make both the denominators equal. Now if I multiply 4, yes Miss Tiffany, go on. Yes.
I'm saying the problem that you gave to us was 3 minus 2. 3/4 minus 2/3.
Yeah.
Where is the multiplication at? I'm
So
trying to
there's
figure.
no multiplication. Yeah, there's no multiplication. But in order to subtract these fractions with each other, we have to have the denominators equal, right?
Right.
Yeah. So, and how to make the denominators equal?
You say after you say you make the denominator equal, I'm thinking we subtract it. So you say 2/3. I mean 3/4, and you write minus 4/4. Am I doing something wrong? Do you say 2/3 minus 4/4? And I got 1/4.
Yeah.
One
So,
over.
yeah, that's fine. But the problem is that you can, so when I do this, okay, so what you are saying is 3 over 4, and in order to make this equal, when I subtract 3 over 3, you are doing this one, this thing, right?
Right.
Yeah. So now see, now we have again a problem. We have 3 over 4 subtracted with 3 over 3. So there are two problems. I
But
again don't
3/4
know.
subtracted over 4/4, and then I said not 3/3. I did 4/4,
Okay.
and
Yeah.
then I said 2/3. But it's supposed to be. I ain't got confused.
No, it's fine. It's fine.
But
So
I
let
got confused.
so you did this, right?
Yeah, and then I wrote next to it 2/3. It's supposed to be two. You was right at first. I was trying to get it how you had it in the left on the left side, the method on the left side, but it was supposed to be the other way around.
Yeah. No, it's fine. So you did this.
Yeah, but I
Okay.
supposed to be 3/3.
Yeah. So what we are doing here, so what you did here is you subtracted 1. This 4 over 4 is 1, right?
Right.
So you subtracted 1 with a number. So you're not supposed to subtract a number. So when you subtract 1, it changes the number, right?
Right.
You subtracted 1 here and you subtracted 1 there too. So essentially you subtracted 2 from the whole answer.
Mm.
So when you subtract something, it changes the number. We don't want to change the number, right? So what we do is we multiply it. So
So
when I
I thought subtraction it meant addition and multiplication mean division. I mean,
yes,
yeah, multiplication is division.
no, in fractions that does not happen. So what we do here is when we have to add two fractions or we have to subtract two fractions, we just want to make the denominators equal.
Where's
And
Miss Fantasia at? Because I went over this with Miss Fantasia. Everything that you're teaching me, it's like really confusing me. Everything because everything that I've been over, I had already went over these things that you had already taught. You teaching us right now? No,
okay,
no, towards you, Miss Vipul. But Miss Fantasia, we had already went over this in class. I'm trying to figure out like why I'm getting like even more confused because I have
okay,
everything what you're teaching us in the notes, and I went over this in class. I did worksheets on all this stuff you're teaching us, and where right now I'm kind of way like confused because I'm trying to figure out the way she taught us, the way you teaching us. I have already been over all of this stuff. I guess I just need to talk to her because I'm getting like very confused, and I don't want to confuse myself any longer. I understand you. I'm not trying to. I'm trying to see where I'm starting off at and where we going from here. Cause I'm already like I already went over these things like in class already before you came. So I'm trying
okay,
to figure out what's going on. Is
okay.
Miss Tracy in or Miss Fantasia? Is they around?
I don't think she is in the class right now, but yes, I completely understand because too many chefs spoil the broth. So that's fine. So I know if you are comfortable with what you have learned, that's fine.
Yeah,
So
it's kind of crashing like from what what I'm saying, because I'm looking at the positive and the negative, and well, we
yeah,
multiply, you divide, and that's not what you're teaching. We did the greater than, less than, and everything like that. I'm trying to figure out like what are we doing right now? Like it's crashing from what I have already kind of learned and remembered.
okay, okay, it's
I'm not
fine.
understanding.
Yeah, it's fine if you don't if you want to try the other method, that's fine with me too. So what I'll be doing is I'll be showing some other methods so other students or other learners can use any method you want to use. So because I was told that fractions and decimals and percentages are not taught in this session, so in this session we are trying something new, and so it's fine
Correct. That's what I'm trying to figure out. Do I still need to be here because I have notes. I have Miss Fantasia taught me all of these steps and everything that you're teaching me, and I'm
okay,
trying to figure
okay.
out, do I need to be here or
So
do I
the
need to?
yeah, so what I'm just saying is that you can see the questions, you can solve it in your way and see if you get
I
the.
don't know where to start it. Like I'm confused because I'm trying to figure out what are we learning. Like what is this just fractions or is this fractions decimals all together? I'm trying to figure out how it's going. Like I don't get it. I don't understand it. Period. Like I don't understand it. I'm like confused.
Excuse me. Hey, Vipul, this is Tracy. Hey, Tiff, let's talk in Google Hangouts real quick, and Vipul, I'll update you.
Okay, yeah, that's fine. Thank you. And yes, you can let me know anytime you have any problem. So,
Thanks, Tiff. See you. I'm finna call you on Google Hangouts.
Okay. Okay.
okay, so for the rest of the class, I hope everyone else got this. So can we move on from this from the subtraction of the fractions? If not, you can raise your hand, and otherwise it's fine then if we can move on.
Yeah, if the
Because
answer is one, if the answer is 112, we can continue on.
yeah,
Yeah.
so the answer is 112. So now moving on to multiplication of fractions. So can everyone see this? If not, you can raise your hand.
I can see it.
In multiplication of fractions, you do not have to worry about denominators anymore. We have to worry about denominators when adding or subtracting the fractions. In multiplication of the fractions, we just multiply numerator with numerator and denominator with denominator. Yes, Miss Anderson?
Correct answer 1/12 because what happened was my tablet keeps cutting off, so
Okay.
I have to keep coming back on. So was that the correct answer?
Yes, the correct answer was 1/12. Every one of you got the correct answer.
Okay, I was trying to find out because my tablet keep cutting. I have to keep coming back in.
No, I understand these things happen. So yes, your answer was
Okay,
so.
okay, thank you.
Hello, Miss Walleen. What we are doing today is we are just writing the summary of fractions, decimal, and percentages. So first we saw how to compare the fractions with similar denominators. Okay, Miss Dawn, yes, we will get back to the multiplication part. I know you are fast. So first we saw how to compare fractions with similar denominators. We just simply compare the numerators. Then we saw the addition of fractions with similar denominators. We simply added the numerators and wrote the denominators as it is. Then we saw what happens when the denominators are not equal. Someone's mic is on, so I'm just going to. Okay, Miss Anderson, can you please mute your mic because it's still on.
The tablet went off, and I asked him. I went back on, and I asked him. I said I answered 112.
Miss Dawn and Miss Anderson, both of your mics. Okay, Miss Dawn, you got your mic on mute. Miss Anderson, can you please? Okay, so back on the fractions. So when the denominators are not equal, what we do is we try to make them equal. And how we make them equal? We multiply the other denominator with them. So 3 is multiplied by 5, and we use the 5 in the numerator because we multiplied in the denominator. And in the same procedure, we multiply 4/5 with 3/3. And then we solve for it, and we get 10/15 plus 12/15. Now the denominators are equal, so the answer is 22/15. Now in the same fashion, we compare the fractions where the denominators are not equal. In the same fashion, we multiply 2/3 with 4/4, and we multiply 3/4 with 3/3. So the answer gets 8/12 and 9/12. So 9/12 is obviously bigger than 8/12. And in the same fashion, what we try to do is 3/4 subtracted with 2/3. We use the same formula and we got the answer 1/12. Now coming back to the multiplication, if I get 3/4 multiplied with 2/5, what I do is I multiply numerator with numerator and denominator with denominator. I do not worry about the denominators being the same or not. So the answer is 6/20. Now dividing the fractions. If I get a fractions like 2/5 divided by 3/4, what we do is we take this fraction, we invert this. The inversion of 4/3 is 3/4 is 4/3, and we convert this division sign into multiplication sign. So what we get is 2/5 multiplied with 4/3. Now we use the basic multiplication. 2 is multiplied by 4, I get 8, and 5 is multiplied by 3, I get 15. So the answer is 8 over 15 for the question 2 over 5 divided by 3 over 4. Till now, anyone have any doubt about anything? Okay, perfect. Now reduction. How we reduce the fraction? 22 over 32. Now suppose we have a fraction like this one. How to reduce this fraction? So first we try to divide both of them by 2. So yes, both of them gets divided by 2, and we write 11 over 16. Now we try to divide it by 2, 11 won't get divided by 2, then we try 3, both of them, 11 won't get divided by 3, then we try 4, then we try 5, then 6, then 7, ultimately we will see that 11 won't get divided by anything, so the answer will be 11 over 16 for this, so it won't get further reduced. So now everyone try this. This is 24. I'm sorry about my drawing. This is 24 over 30. So everyone please try to solve this in your notebook and write the answer in chat. Okay, Miss Dawn got the answer as 2 over 15, and Mr. Dwayne got the answer as 4 over 5. Miss Dawn, Miss Dawn, did you want to try, did you write 2 over 15? Is that correct? Okay, Miss Dawn got disconnected. Yes, Miss Warleen, please go on. Miss Warleen, can you hear me? Okay.
Yes, I can hear you.
Yes. Okay. Please go on.
I wrote it in the chat.
Okay, 4 over 5. Yeah. Okay, that's good. Miss Anderson, if you can hear me, if you solved it, you can write in the chat.
I can hear you too. I hear you.
Okay, that's good. Okay, so Miss Dawn.
Mr. V.
Yes, Miss Dawn?
What was the answer?
Okay, so the answer is, let me solve this. So first I try to divide both of them with 2, and yes, both of them gets divided by 2. So the next thing is what I get is 12 over 15. Miss Dawn, I think you mistakenly wrote it as 2 over 15. If you get 12 over 15, then you further try to reduce them by dividing both of them by 2. Since both of them do not get divided by 2, I try to divide both of them with 3. And what I get after dividing both of them by 3 is 4 over 5. And then when I try to further divide them by any number, they won't get divided, and hence the final answer is 4 over 5. Miss Dawn, did you understand it?
Yes, I wrote the problem down wrong.
Yeah, that's what I figured. So it's an easy thing to reduce a fraction. Now let's see on how to convert, how we saw how to convert a mixed fraction into an improper fraction. So if I get a mixed fraction like this one, how to convert this into an improper fraction? So what we do is, so in the formula, what we do is we multiply denominator with the whole. We solve this first, then we add the numerator. You can write this down in your notebooks if you have already not written it, and we place the denominator as it is. So how we can solve this is the denominator is 5 multiplied by whole, which is 3, added with 2, divided by, divided by 5. So this is 15 plus 2 divided by 5. So the answer is 17 over 5. So this is how we convert mixed fraction into improper fraction. Now we will see how to convert improper fractions into mixed fractions. So if I get something like this, so what I do is simply divide it. And I will not use decimals. Whenever I stop getting the remainder greater than 4, I stop there. 4, it goes it into 2 times, subtracted with 8. I get 3 here. Now as 3 is smaller than 4, I just stop. What I do is I write the quotient in the whole part, I write the remainder here, and I write the denominator as it is. So here the quotient is 2, the remainder is 3, and the denominator will remain as it is. So this is how we convert improper fraction into mixed fraction. So if anyone have any doubts till this part, in any fraction part, then we can solve it. Otherwise, let's move on. Okay, perfect. Now let's move to decimals. So what decimal meant? Okay, yes, Miss Anderson, please go on. Just wait for a second. Okay, yes, Miss Anderson, you can unmute your mic.
Said I really understand now, because at first I didn't really understand what you were doing with the infractions, but I understand exactly now.
Okay, that's good. That's why we are doing fractions, decimal, and percentage all together today. Because sometimes I understand it gets confusing with lots of different techniques.
Okay, thank you.
Yeah, and thank you for being patient with me. So, okay, so how to write this decimals? So what this decimal means, let's take another digit here, 6. So what this decimal means is 6 multiplied with 10 because it is at tens place, 2 multiplied with 1 because it is at ones place, 3 over 10. Yes, Miss Anderson, please go on.
Sometimes if with you working the problem out instead of letting us help work the problem out, it might work better because you're working the problem out and we're not working the problem out with you.
Yes, I try to take care of that, but yeah, I will give you more problems to work for. So yes, I will do that. Thank you.
Oh,
Uh, I'll do that.
okay.
Yeah. And yes, Miss Dawn, please go on.
I don't understand what you're doing right now.
Okay, so what I'm doing is just writing the decimal on how we understood the decimals and what decimals mean. So here, when we get a decimal like 62.345, what 6 in 60 means 6 is multiplied by 10, right? This means 60. And 2 is multiplied 1, right? This means 2. And this is zero point 0.3. So zero point 0.3 is 3 over 10. And 0.04, this is at hundredths place. So I'm just writing on where each one, what is their place. So 4 is at hundredths place, so this will be written as 4 over 100. And 5 is at thousands place, so this will be written as 5 over 1000. So, just that's what I'm writing. And as you know, everyone know that 3 can be written as 003, right? I can add as many zeros as I want in the left of the 3 because this is a whole number. So if there is a decimal and it is 4, I can write as many decimals as I want in the right of the 4 when 4 is a decimal. Okay. So now let's see comparing the decimals. So 3.2 and 32. So now everyone write in the chat what you think is the greater, right? Which one is the greater, the left one or the right one? Just write left or right. If you think left is the greater one, write left. If you think right is the greater one, write right. Okay, this is confusing, but yeah, I think you got it. Okay, Miss Dawn?
Huh?
You are supposed to write something, right, left or right, anything.
Okay. Okay.
Miss Dawn.
I'm coming.
Okay, so you think 3.2 is greater than 32? Okay, yeah, let's see. Okay, so what we do is we always find, in comparing, we always find the leftmost digit. So here, in the right side, the leftmost digit is tens place, right? So we compare the tens with tens. We always compare. If we find tens somewhere, we compare tens with tens. And if tens and tens are same, the number at the position of tens are same, then we compare ones. And if the ones are same, then we go on at the decimal of tenths, and so on and on. So we go at hundreds, then thousands. So let's see, here at tens place I have 3, and here at tens place there is nothing. So when there is nothing, I can write 0, right? So I compare tens place with the tens place of both the numbers, and here there is a 0, here there is a 3. So 3 is greater than 0, right? So we write 32 is greater than 3.2. It's fine if you don't understand this. Let's take another example. 16.38 and 16.4. Now try to find the greater of both the numbers. Which number is greater, the left or the right? So what we do is, first we compare tens with tens, ones with ones, tenths with tenths, and hundreds with hundreds, if everything is same. Okay. Okay. So, Miss Anderson, can you hear me? So, why you think that the left one is the greater? It's fine. It can be greater.
Excuse me, you're gonna count out 0.
Sorry.
You're gonna cancel out that 0 on 1640, and
Okay.
1648. You're gonna probably add that 0 in front of the 16. So I still say it's greater.
Okay. Yeah. So let's see. But how we do is, we find the leftmost digit in both the numbers. So here the leftmost digit is 1, right? And the 1 is at tens place. Here the leftmost digit is at 1, and this one is at tens place. So both of these are at tens place. So we compare them. So 1 and 1, now both are equal. So the tens place is fine. So we move on to the ones place now. So at the ones place we find 6. Now 6 and 6 both are equal. So we move on to the next number. We move on to the 10th digit. The 10th digit is 4 and 3. Now at 10th digit 4 is greater than 3. Hence we do not move on, and we write the answer as this. So let me demonstrate you with another example.
One was the correct.
So the right one was greater number. So how we do this is, suppose I have 3.4 and here I have 0.37. Now how we find the greater number? Yes, Miss Anderson, please go on.
You lost me because I'm thinking that the one on the left is greater than the one on the right.
So you thought, you think one on the left here or here in the next question?
No, in the first one we were doing.
Okay, in 16.38?
Yes.
Okay, So you think 16.38 is greater than 16.4, right? 40.
Yeah,
Okay.
yeah.
And
Because
how?
you're gonna cancel that. You're gonna cancel that zero out.
Okay, that's fine. I can cancel the zero. Yeah, because the zero does not matter. Yeah.
You would still have 38.
Okay, so this is 16.38 and this is 16.4, right?
Yeah.
And you saw that 38 is greater than 4, right? Right?
Right.
Okay, but that's not how we deal with decimals. And this is why decimal is different than the whole number. What we do is we compare digit by digit. We do not compare the whole number with the other number. We compare it digit by digit. So we compare 1 with 1 first, then we move on to 6 with 6, then we move on to 3 with 4. We do not take 8 into consideration just now.
Okay, I understand now. You don't take the 8 in consideration at all. See, I
Yeah,
was
because
taking 8 in consideration and rounding it off as a whole number. Okay.
yeah. So
Okay.
what we do in decimals is we compare it one by one. So let's take another example. This example will be a good one. I'll change the example frequently. Okay, so let's take 53.4 and here we take 53.26. Now everyone please solve which one is greater, left or right. Okay, Miss Anderson and Miss Dawn, I'm waiting for your answers. Okay. Okay, so everyone got this one correct? Now let's do this. Which one is greater? Yes, Miss Anderson, please go on.
You didn't write anything down. We still got the same
Yeah,
question.
what I did was I added 1 in the front of the right number. It is now
Oh,
153.26. Yeah.
I see. I see.
Yeah. Miss Dawn, we are waiting for your answer. Okay, so yeah, everyone got the answer correct. So just one more for my own sake of. Okay, so what do you think about this one? Okay, please everyone write the answer in the chat box.
Did you see my answer, Mr. DePaul?
Yeah, Mr. Dane, I got your answer. Okay, and Miss Anderson and Miss Dawn. Okay, Miss Dawn got the answer, and Miss Anderson.
My battery is going out. I gotta charge my laptop.
Sure, yeah. This happens. Okay, so I hope you can still hear me. Yes, Miss Anderson, please go on. Okay, I think she went to charge her laptop. So what we do here is we compare zero. So there is no zero here, right? So there is one place which is zero. So we know in the whole number we can always add a zero. So we add a zero here. We compare zero with zero. Both are same. Now we move on to tenth place. Here at tenth place there is four. Both of them are four. So we move on to the next digit. Here there is 0 at hundredth place. Now we all know that we can add as much zeros as we want after the decimal. So I can essentially make both of the numbers same by adding zeros, because I can add zeros, right? I can add zeros here, I can add zeros here. So in order to compare both the numbers, I added four zeros here. So at hundredth place, the zero is same. At thousandth place, the zero is same, and so on. Both the zeros are same. So both the numbers are same. So the correct answer is this number is equal to this number. Do you get it now? Or is there a doubt? So you can raise your hand. Miss Walleen, Miss Dawn.
That's what I thought. Because you can't add zeros.
Sorry?
I said that's what I started to put equal because they're both. You can add zeros to.
Yeah, yeah. So we can add zeros, hence both of them are equal, right?
Yeah, you tricked the.
Okay, so let's move on to the next part of addition of decimals. Miss Barbara, we can see your video, so I am going to turn off your video. I just did. Okay, so let's move on to addition of the decimals. So if I say this to add 2.3 with 43.45, then what you do is you simply align the fractions. You align the decimal. I'm so sorry. So you simply align the decimal. So you write 2.3 here. You align the decimals here, and you align the decimal here. You write according to decimal 43.45. Now in order to add, you can add a 0 here, you can add a 0 here. Now 0 plus 5 is 5, 3 plus 4 is 7, 2 plus 3 is 5, and 0 plus 4 is 45. So the answer comes as 45.75. I hope everyone is clear with this one. And in the same fashion, if there was subtraction here instead of the addition, what you can do is you can just place a subtract sign and do the subtraction in the usual way. So I'm not going to subtract this because this will come out as negative and it is out of our scope. But yeah, you can do it in the same way. Now multiplication of decimals. When you get a number like this, 2.3 multiplied by 1.5, what you do is you write this as 2.3 multiplied with 1.5, and then you just ignore the decimals and you multiply, you consider them as whole numbers. So you consider them as 23 multiplied by 15. So I don't know what your method of multiplication is, but eventually you will get 345 by multiplying both the numbers. Now you count the number of digits after the decimal. The number of digits after the decimal is equal to 2. Hence you place the decimal here so as to make 2 digits in the right side of the decimal. So in the chat box, Miss Dawn write 3.35. Miss Dawn, probably you got the multiplication wrong, but yeah, you got the overall concept right. So the answer is 3.45. So this is how you do multiplication. Now converting decimals to fraction. Now suppose I have a fraction like, I have a decimal like this one, 2.3. It seems like my favorite decimal to begin with. Now when I have a fraction like this one, I count the number of digits in the right of the decimal. So the number of digits in the right of decimal is 1, right? So I convert this into, I write this as it is, and I place 1 0 because there is just one digit in. So can everyone do this for me now? So 3.50, convert this into a fraction. You do not have to reduce it. If you don't reduce it, that's fine. You just convert this into a simple fraction. Okay, so I got some answers in the chat. Mr. Dwayne Roth, 350 over 100. So I'm waiting for the other answers. Okay, Miss Warleen got 350 over 100. Miss Tiffany and Miss Dawn, if you both are here, and already they put me in Khan Academy. Oh, it's fine if you because we have already covered this in the class, Miss Dawn. I know even we have completed this. What we are just doing is we are solving the summary. Why? Because sometimes it gets confusing. So in order to eventually wrap this up, we are just doing a summary. So if you can play along, because we saw that still we are getting some answers incorrect, right? So hence we are doing this again, and we are just completing it very fastly. So I hope everyone got the answers as 350 over 100. Now, and in order to convert fractions back into decimal, so I have a fraction like this. In order to convert it back into a decimal, what I use is I just divide it till the thousands place. So I write numerator here, I write denominator here, and I write a decimal here, I write a 0 here, I write a decimal here, and I just divide it. So the answer is 0.6. So, and percentages, we just remembered how to convert the percentages in the first part of today's lecture. So the 20% can be converted into fractions as just writing 20 and divided by 100. Always divided by 100 no matter what. And this can be converted into decimal as there are 2 zeros in the denominator, hence we have to place 2 digits in the right of the decimal. So that's pretty much it. So now we are back to our diagram. So this is our diagram. So this is it. We have completed fractions, decimals, and percentages. Now, if you have any doubt or if you have any question in the worksheets, we can solve it now. I'll help you up. So now, today we got completed on 12, but you still have time, so you can utilize it. You can ask any question. And if you don't understand any part, you can speak up.
Are you talking about the worksheet that you just put in today, or the one from the other day?
Yeah. I just put in one worksheet today. You can discuss about that too. And if you want to discuss about any other worksheets which were given in the previous classes, you can discuss about them as well.
Okay, I just wanted to know because I just got the one for today and word problems.
Yeah, so you have the time to solve the word problems. I post another worksheet involving all the questions of fractions, percentages, and decimals. You have to solve that too. So do anyone have any doubt?
No, I hope completed that. I completed that other worksheet that you gave us.
Yeah, that's great. That's really good. So that's it for the today's class. So bye all, and have a good day. I am still available online. If you have any doubt, if you want to go over any concept, you can text me, call me, put a message on Google Hangouts.
Okay, I'll send you over the worksheet that I did the other day.
Yeah, that would be great. That would be great. Thank you. And please show some of your work as well if you can.
Yeah, I did.
Okay, and thank you, Miss Warleen, for sticking around. And I hope we will have better classes. So I'm learning with you all. So tomorrow we will do many questions and some more concepts. and I'll put a feedback form as well, so you all can give feedback to me so that I can, help you better and help myself better. So thank you all and have a good day and take care of yourself, please.